Hello, this is Alan Roble again on continuing the discussion on process, one of the ECL's built-ins, enterprise control language built-in functions. I showed you in the previous video, I showed you the workings of process and actually pointed out that the two transforms run independently of each other. So just remind you of that. So here we are. We have the first iteration of process. Now both these left and right inputs to the two transforms just are presented independently to those transforms, and which is okay 90% of the time. It's just that if you've got a particularly expensive operation that you want the results from in both transforms, the way it stands, you'll have to run that expensive operation twice. So what's nice is to be able to share results of any such operation between the two transforms. So this is what I'm going to show you here in this ECL. So this ECL is identical functionality to my previous video on the workings of process, but I'm going to share the results between transforms here. And right, so this was given to me by Gavin Halliday from the core team. What you do here is you've got the same D input as in my first video. I've got the same initial state for the right hand side. Now this time you've got, when you specify the transforms, you're actually specifying them via the module. So you've got module my function. Actually, that's very badly called. I should have called it my, that's not a my function, that's my module. Sorry about that. That's, why did I do? Right, that's a bit more reasonable. And inside that module, you've got true transforms. So make the left hand side and make the right hand side. And so what you can do inside a module is you can have functionality that's shared between the two transforms here, and this should be get executed once. And in this example here, my shared information result is the tally, the current tally from the right hand side, and it's passed in to the output as the len, but on the row transform, the right hand side transform, it actually is used to accumulate the tally for input on the next iteration. So if I run this now, this will have exactly the same output as the previous example. So the tally of characters before Nina is 4, before Colin and John is 8, and things like that. That's identical functionality. So you can, well, let's show you another example here. Let's call that my module. You can notice the case insensitivity to here, and here I've put the length of val is also shared, and in fact the functionality here is the len in the output is lv plus t, and actually the tally is in fact the same transform. And what this will do will include the length of the current records text in its own tally. So if I submit that, there we go, Anna 817. So again, identical functionality to the to what I was showing in the first video, but you can share results between transforms this way. I didn't mention the other video, you can play around with things to give yourself some understanding of what's going on. So for example, I could put 111 in as the initial value to the right hand side and you can see what it does. It's great, these small little programs, because you really get your ideas straight on them. And there we are. We've got 115, 11 plus 4, so the 4 of Anna went in there, plus the 111 there. Or you could start off with 0, let's say, and let's put yan initial length of 200 in there. Let's see what happens then. And all these kind of little runs just give you a better understanding of what's going on, and absolutely nothing changed there. Why was that? Oh, because LV plus T, length of val, which is still that, it's not using the inputs at all. So actually that didn't have any effect on, because I'm not accumulating the left length anywhere. But anyway, there you are. That's just playing around, seeing how it behaves. So I think I've exhausted all I know about process, and I'll move on to the next video. All the best. Bye.